All right, hello 20-1 students. So today we're looking at the cosine law. So if you remember in our last lesson, we were looking at the sine law, and we finished up by making that lesson into two parts, with the second part covering the ambiguous case. So we're going to move on to a different law that we can use in order to solve for unknown components in oblique triangles. So the cosine law can be used to determine an unknown side length or angle. Angle measure in an acute triangle. So just like sine law, the cosine law does not require a right triangle. Okay. So at the end of this session, I'll quickly show you guys, also have a little bit of a review summary where you guys can kind of basically sum up, like, where do you use each one of these different methods we've looked at in chapter 2. And yeah, hopefully that'll help you in your studying to really understand where do you apply all of these different situations and rules. Okay, so basically the sine law is summarized here. You also have one version of that on your data sheet here. So you have the cosine law. Here's the sine law we covered. We have the cosine law, two kind of versions of it here. Now, as you'll see, you're only given on your data sheet the c squared one. So that would be this one here. And so basically what we're saying here is side C squared is equal to a squared plus b squared, so those are both sides, minus 2 times by side A times by side B, times by cosine of angle C. Okay, so you do have to have the angle here and these two sides in order to solve for the side that's across from the angle that you know, which is between the two sides that you know. Okay, and so if you can kind of keep that in mind, basically we can also rearrange this rule to solve for sides A or B, right? So if we're solving for side A, we need to have the angle across from it, so cosine A, and then we need to have the side lengths of the two sides that surround angle A. Okay, same thing here for B. We need to have cosine of angle B and the two sides that contain angle B. Okay. Now the other thing that can happen is if you need to find an angle, you can, and you're given cosine. Oh, why did I do that for you guys? Oh, probably to show you guys. So on your data sheet here, you're going to have cosine of C, a squared plus b squared minus c squared divided by 2ab. And so hopefully you can see from this, the pattern here is basically, if you have angle C, for example, then the first two things you need to add are the sides that contain angle C, and then subtract the side opposite, and then divide it by 2 times, again, the two sides that enclose side C. So if we're solving for angle A, how do we rearrange that? Well, we would need to have, right, like we just said, the two sides that enclose angle A, which would be B and C. So we have to do b squared plus c squared, and then minus the side that's opposite the angle you have. So if we're looking for cosine A, then we're going to subtract off side A, and then we can divide it by the two sides that enclose the angle. So it's going to be 2 times by b times by c, which is what we see here. Okay, so again, with both of these rules, regardless of which one you're using, you can solve for any side or angle. You just have to make sure that you pay attention to how you manipulate which sides are going where in the equation. Okay, and we'll do practice questions where you'll see that we'll actually go through and do that. So hopefully that'll help you out. Okay, so let's try some examples. In this first one, it says determine the unknown side length to the nearest tenth of a centimeter. So we're looking for side x here. We have an angle x, so we basically have the angle directly across from the side, and then we have the two sides that contain our known angle, right? So let's just start out by writing down what we have. We have cosine of x, which is basically cosine 46. And we're looking for side x. we have side straight across from y is going to be side little y, which is 15. I'm not going to worry about units for now because we're just going to work with the numbers. And then we have this side is across from angle z, so that's side z, which is going to be 18. Okay, so now I basically want to think about if I'm looking for x and I have my formula, or sorry, I'm looking for side x. Do I have, according to our formula, in order to solve for side, you need to have the angle that corresponds with it. And so in this case, we do have angle x, which corresponds with side x. And so everything should be pretty straightforward. These should be the two sides containing the angle, which they are, z and y, minus 2 times by, again, this will be zy, and then cosine of the angle, which in this case will be x. Okay, so we can basically substitute that in. I don't know, I'm trying to figure out if I have enough room for both of these. Okay, so basically we're going to say x squared is going to be equal to the two sides that contain our angle, so 18 squared, doesn't matter how you assign these ones, plus 15 squared, minus 2 times by, again, the two sides that contain the angle, so 18 times 15. And then times by cosine of angle C, which in this case is going to be, because we're looking for side x, so it's going to be angle x, so cosine 46. Okay, and then basically if we start combining some of that stuff, we're going to end up with, so like I always encourage you guys to do, make sure that you try it in your calculation to make sure you get the order of operations correctly. The other thing is I've found like sometimes when I'm just glancing at this formula sheet, I've made the mistake of not paying attention to that being a multiplied by, and I've subtracted that off. So just make sure you're paying careful attention to which operations are happening. So in order to do this, you're going to have to make sure that you add the 18 squared plus 15 squared, so you get one whole number. And then 2 times 18 times 15 times cosine 46 should be another whole number. And then once you have those two numbers, you can subtract them. The other component is, so if we do all that, you should get x squared equals 173.88, and kind of like an extended decimal there. So the other thing is just with Pythagoras, we don't want to have a squared value here, so we have to square root both sides. And so that leaves us with x being equal to 13 point, if we round for decimals, because it asked us for the nearest tenth, so we need to round it to 1 decimal place. So we would say x is 13.2 centimeters. Okay. I forgot that I put that in. So if you want to pause the video a second, there is a chance for you to try your own version of the one we just did. So if you want to pause it, give that one a try. The answer you should get would be 6.9 centimeters. Okay. All right. So example 2, determine the angle R to the nearest whole number. Okay. So we're looking for this angle here, and so I'm going to start putting down my variables. Angle R is our question mark. What do we have? Well, the two sides that contain the angle would be side P and side Q. So we have P is 5.9, Q is 6.2. And in this case, we also have side R, right across from that angle that we're looking for. So R is 2.3. Okay, so basically if we're looking for an angle, we're going to be using this second version of the law. So we're going to say cosine of angle R is going to be equal to, remember that these two have to be the sides that enclose the angle you're looking for. So that would be P and Q. And then you can subtract off the side that's opposite the angle, and then divide by 2 times by, again, those two sides that enclose it. So try and keep this in vision here. So we're going to do cosine of R is going to be equal to a squared plus b squared, which will be p squared plus q squared, 5.9 squared plus 6.2 squared, minus c squared. So that's going to be the side that's opposite from your angle. So 2.3 squared. And then we want to divide that by 2 times by p times q. So 2 times by 5.9 times by 6.2. Okay, and so when you get all of this together, you should end up with 0.928, an extended decimal there, right? So making sure not to round, we need to think here, if cosine of r is equal to 0.928, what we actually need is angle r. So remember that means we need to do the inverse of cosine to solve for r. So we're going to do cosine minus 1 of 0.928. And that's going to give us an angle of 21.73, and it says round it to the nearest whole number. So if we have 21.7, we're rounding it up to 22 degrees. Okay. All right, so that's how you work with the angle style ones. Now again, you have a chance to try this one on your own. So if you want, you can pause the video and give that one a try. Your answer for it should be 74 degrees. Let's see, and then we're going to try one more example. I believe this is our last one. Yeah. So this one's more of a word problem. So it says in triangle ABC, we have side A is equal to 11, B is equal to 5, and angle C is equal to 20 degrees. You need to sketch a diagram and determine the length of the unknown side and measures of the unknown angle. So basically you need to solve the triangle, okay, to the nearest tenth. So with this one, when I'm drawing it, I actually, just because I think I mentioned to you guys in the previous one that I don't like it when I can't have like a bit of an idea of the visualization. So I actually just ended up scaling these sizes down to 1/2. So if that one was 11, I ended up sketching 5.5 centimeters. And then for B was 5, so I made that. So if that's side A, I made this one side B, and so that'd be 5 centimeters. But then angle C was going to be 20 degrees. So basically I would say if this is side A and this is side B over here, side C is going to be over here, which means that this angle here is going to be angle C. Okay, and so just so that I could kind of make sure my triangle might be something close to accurate so that I can kind of visualize things a little bit better, I set this to 20 degrees. So angle C is 20 degrees. And according to what, if I scale this down by 1/2, it's going to be 2.5 centimeters. So basically if I set my ruler to 0 here, right, and this is the correct angle when I have it there, but I want to draw it to the proper length, which was 2.5. So I'm just going to draw it like that. Oops, it's not really filling in. And of course it's not super accurate because I ended up not pushing my ruler back enough, but it's good enough for me to have the general idea of what this triangle is going to look like because the remaining side is just going to connect, right? So this is side A, this was side B, this is obviously going to be side C, and that means that we have angle A up here, angle B up here, I mean down here, and we can fill in our values. So A was going to be 11, B was going to be 5, and this was going to be 20 degrees right there. Okay, so now I have like a little bit of an idea of what this triangle is going to look like. So let's see, sketch a diagram. Yeah, so now we just need to start with determining unknown sides or angles. So the first thing I'm going to look at is solving for side C here, because we do have an angle that's opposite that side and the two sides that enclose that angle. And so we know that if we have that set up, basically we can use the cosine law. So if I want to solve for side C, it's going to be C squared is equal to A squared, so 11 squared, plus B squared, 5 squared, minus 2 times by a times by b, so 2 times by 11 times by 5 times by cosine of angle C, so cosine 20. Okay, and so that's going to give me C squared being equal to 42.63, which is like an extended decimal. So again, you might want to try this in your calculator to make sure you get the correct number, that you're doing order of operations properly in your calculator. And then of course that means we need to square root both sides. So we can say that C is equal to 6 point, if we round it off now to the nearest tenth, it's going to be 6.5 centimeters. Wait, no, not centimeters, we weren't given units, so we're just going to leave it as 6.5. Okay, now remember we had to solve the whole triangle, so that means we also need to know all the unknown angles. So to start out with, let's say we want to solve for angle B. We'll try this guy over here. Okay, so basically what we need to do is rearrange this. So if we're looking for cosine B, I kind of explained to you guys thinking about like the sides that enclose it and things. The other thing you can do is just figure out, right? So if we're doing cosine B, this side that's across from it has to be the one that's subtracted. So B is going to have to be subtracted. So C and A are going to have to be the two that get added together and the two that get multiplied by on the bottom. So it's going to be A squared. Cosine B is going to be equal to 11 squared plus 6.5 squared minus, oh, yeah, now I just messed my own self up. Okay, but yeah, minus the side that's opposite the angle. Okay, so minus 5 squared. Now make sure when you're doing this, though, you're still using the full decimal, not the rounded 6.5, so I should almost do that instead. Because remember, you only round it off to give the answer, not to do any further calculations. And then we're going to do on the bottom 2 times by basically the two sides that aren't across from the angle we're looking for. So not B, but C times A. So 2 times by 11 times by 6.5, and again use that extended decimal. And that's going to give us, let's see, 0.261 as a decimal. Now remember, we actually want to solve for angle B, so we have to do cosine minus 1, the inverse, of 0.261, sorry. And that's going to give us 15.2 something. But we want to round it to the nearest tenth, so we're going to keep it as 15.2 degrees is angle B. So there's another answer. Remember, if you're answering on a test, if you can circle your final answer so that I know for sure what it is, that's very helpful. Now for angle A, we don't need to go through the whole sine law again or cosine law. So actually, and that's something maybe I should have mentioned, is once you have the angles and sides, you could actually use the sine law here as well if you wanted to for this second step. So if you wanted to solve for B, it could be sine of 20 over 6.5 is going to be equal to sine of B, which is our unknown, over 5, right? And so then you could have used sine law there as well, if you're more comfortable with that. So then now our last one, thinking of other alternative methods, would be that we know that all the angles in a triangle sum to 180, right? So for angle A, I'm going to say 180 minus 20 minus, and again I'm going to use my extended decimal here, so 15.183 was actually kind of my extended decimal there. And that's going to give me 144.816, something like that. And looking at this, it makes sense, right? We know that that's an obtuse angle, so it makes sense that that's our number we get. So we can say here angle A is equal to, we want to round to the nearest tenth, 144.8 degrees. And this also makes sense because the 0.8 and the 0.2 are going to add up to a whole. And then, so we would expect that if we do 20 plus 15.2 plus 144.8, we should get 180 right on the dot. Okay. Yeah, so that's basically everything. You will find, I would recommend that you go into the textbook and maybe have a look at, there's a couple of word problem examples where you have to figure out the triangle. Maybe I'll just show you guys really quickly, 2.3. But because those examples were already laid out pretty nicely, I didn't end up adding them into this one. So like, for example, this one here, right? So they give you like, there's a point, there's distances, and you kind of need to draw the triangle yourself. All the calculations will be the same as what we just did, but if you ever need practice working on your ability to visualize word problems, I'd recommend maybe even just look at this, try it on your own, and then see if you get the right answer, because after you're finished, you know, they have the whole solution worked out up here, so you can try that afterwards, and or check your answers basically afterwards, and make sure you are good at visualizing that, because that is an important skill to have. Okay, so you guys have another chance to try your own version of the one we just did here, so you can go ahead and do that. The answers are given at the bottom, and you have an assignment from the textbook to work on. Now, before I wrap up today, I'm just going to really quickly go over this review chart that I made up for you guys. So basically with this review chart, it's just kind of talking about some different strategies we've looked at and when you can use them. So I'm not actually going to make you sit through me writing it all out. So I'm just going to go over the one that's in the filled in notes that are available online. So the first one is sum of angles in a triangle equal 180. And we just used that in the last example, right? So in what situation can you use that? Well, basically you just have to know two angles in any triangle, and you can solve for the third angle, okay? Like we just did. Then what about Pythagorean theorem? Remember, it's really important, and a lot of students end up trying to use this in other types of triangles. You have to have a right triangle to use Pythagorean theorem. So it has to be a triangle that has a 90-degree angle in it. Now, as we looked at in the sine law, sometimes you can break a triangle down into a 90-degree triangle and solve for a side in that way. But there has to be a right angle in whatever triangle you're working with, whether you've kind of artificially constructed it by dividing a triangle in half, for example, or if that's just how the triangle is. You also need to know two sides, and you're just looking for the third side. So that's the only time you can use Pythagorean theorem. And there's an example here. What about SOHCAHTOA? So this is basically using sine, cosine, and tan as being equal to opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. So again, with these, remember you have to use a right triangle, and lots of students get thrown off because we have sine and cosine down here, which we are not using for right triangles. But if you want to use the actual, like just sine is opposite over hypotenuse, for example, it has to be a right triangle. And so in order to use it, you need to know one angle and one side to solve for another side, or you can know two sides and solve for an angle. Okay, so those are the kind of two situations where you can use that. Basically because you can fill in, right? If you have like sine is equal to opposite over hypotenuse, only one of those things can be missing essentially. So it's either an angle or a side. Sine law, so both for sine and cosine law, this is where we can start using oblique triangles, so they do not have to have the 90-degree angle in them. So with sine law, you need to have a side with the angle that's opposite it, plus another side where the angle opposite it is unknown, okay? Wait, let's see, one side and opposite angle, plus another side or angle are known, yeah, but this side and angle have to be opposite each other, because we have like sine A over angle over, no wait, sine A, which is an angle, over side A, which is a side, right? So you have to make sure that you have the paired up set, essentially. So you can solve for a side or an angle using this, just so long as it's opposite something that's known, right? With cosine law, again, you can use an oblique use this for oblique triangles. in this case, you have a couple of different options. You can either, if you know 3 sides of the triangle, you can solve for an angle. Or if you know 2 sides and a contained angle, then you can solve for the 3rd side. Okay. And then, yeah, you can like always, of course, like manipulate the equation around a little bit to help you out with whatever you're looking for. But basically, those are going to be the situations where you can use that. Okay. So, basically, as you guys move forward with this, I did attach in, I don't think I put it into this package here, but so this is all triangles, so which is extra practice. This is a good way to apply the chart we just looked at, because essentially what it's going to be is you're not going to know what to use for each of these, right? Because it's not like, oh, we're on section sine law, so I have to use the sine law, because that's quite simple, right? It's harder for you to figure out what do you have to do. So there's a bunch of questions in here, so you have to determine, you know, which strategy you're going to use, and of course the answers are at the back here to help you out with that. There's also a trigonometry practice test back here. So obviously good practice, and there's an answer key at the back as well. And then there's another practice. Sorry guys, microphone cut out. I guess you guys are getting used to that. So again, answers at the back, and then there's one more still, like a trig practice exam. But this one I actually posted the blank one in a separate review section, so it's not attached to the notes. And then I've also posted this key as well. Okay, so you guys have tons and tons of extra practice to do to get yourself ready for the test. So yeah, all the best with your studies, and I will see you in chapter 3.